Next, let's look at the homework. But before I do, I should have probably mentioned that you should put all the formulas on the same page like this, and then that you can refer to it easier, or maybe just take a screenshot of this thing, and that would be okay too. Well, either way, let's begin. First, I want to talk about problem 11. Which is just a short little problem. Okay, problem 11, we have 2 sine pi over 4, 2 cosine pi over 4. Now that reminds you of this from the very first double angle formula, which is sine 2 theta is 2 sine theta cosine theta, as long as the 2 thetas are the same. So what is 2 sine, what were we doing? Problem 11. Okay, so what is 2 sine 2 sine pi over 4, 2 cosine pi over 4, then we will take out the extra 2, okay, and to fit the formula. So the formula, this thing has an extra 2, so we'll factor that out. So the rest is becomes 2 sine theta cosine theta with theta equal to pi over 4, and that's equals to sine 2 theta. So the entire answer would be 2 times sine 2 theta, and or where theta is pi over 4. 2 theta, okay, where theta is pi over 4, which is 2 times sine of pi over 2, and that is and that should be the answer actually. And let's see if that is correct. And that is correct. So let's move on to the next problem, 21. What are we doing here? We need to find sine, cosine, and tangent of some angles, and if sine x is negative 12 over 13, and x is in quadrant 3. So that's problem 21. Let me write it down. Okay, we have sine x equal to minus 12 over 13, and the angle is in quadrant 3. So let's draw this thing out a little bit. The quadrants count as this way, 1, 2, 3. So x is somewhere in here, okay? And it is 12. So then the sine would be, which is opposite, opposite divided by hypotenuse. So this is 12, and this is 13, which makes sense because the y value going down would be negative. So sine x will be a negative 12 over 13. And what is this distance? That would be 13 squared minus 12 squared, which is 25, and the square root, and take the square root, will be 5. And the reason I can do that so fast is because I remember that the 5, 12, 13 is another measurement of a right angle triangle. The most common one will be the 3, 4, 5 triangle. Okay, but this is another one of them. It's 5, 12, 13. All right. So now we need to calculate what is sine of x over 2. Sine of x over 2 would be x over 2 would be equal to, and let's dig out some formula that helps us calculate it. Well, according to the half angle formula, sine of x over 2, let me fix my x, it's too ugly. Okay, let's look at our formulas. See, the half angle formula states the sine alpha over 2 over here is 1 minus cosine alpha over 2 and take the square root, which means that to calculate this thing, we need to figure out what cosine alpha over 2 is. So let's look at our triangle here. Okay, and this is the angle, and we only care about this part. So anyway, so the cosine of this angle, x, okay, cosine of the angle x is would be 5 over 13. So let's write that down. Cosine of x is equal to 5 over 13. But next, let's consider the sign. The 5 is on the minus side of the x-axis, the negative side. Therefore, this cosine is actually negative. Yeah. Anyway, so that's that. So then, so now that we know what cosine x is, we can follow this formula to figure out what sine x over 2 is. And by the way, if x is down here, x over 2 will be somewhere up here, which means the y value will be positive. So we're going to pick the positive value in this formula that involves a square root. Anytime you have a formula with a square root, there's always two options, positive or negative. But in this case, we'll choose the positive one. So this equals to the square root of 1 minus cosine alpha. I mean cosine, in this case, cosine x, which is minus 5 over 13. And then divided by 2. And that would be equal to, we'll ignore that a little bit. So this here will be equal to, that becomes a 1 plus 5 over 13 that over 2, which is that 1 plus 5 over 13, that's 13 plus 5, that'll be 18 over 13, okay? And then divided by 2, we'll put a 2 right here. Okay, that's 18, well, wait a second, that is divided, no, I don't know if, can this 2 be right there? Yeah, I think it should be okay. Anyway, so then that is equal to, that cancels out, and that will be 9 over 13. So that should be the answer. Although the book probably wants us to rationalize something, so let me check. Next, let's not forget it. Holding this thing. Anyway, so next 20. What happened here? I lost. Next problem 25. Well, there's nothing out of it. Okay, problem 25. What was I doing? 21. Yes. Which is let's go 25, where we have a triangle here. Oops, the first line I drew is wrong. Still wrong. No. 2 theta. Why is there a negative sign? Cosine 2 theta squared minus sine squared. Doesn't matter. I'm not sure. Yeah, the negative sign. Cosine of theta equals to 12 over 13, 2 theta. So, why is it negative? Did I do it wrong? I'm not sure, did I? This is problem 25, is it? What is negative? 2 sine squared, 2 cosine squared. Might be negative, right? Right. Cosine. We got it's negative or not. It might be, yeah. It might be not. Minus sine squared in this case. Yeah, some technical. Some cosine is no, in this case it's not. Let's see, because theta what's theta anyway? Theta 22 times 2 is 45 cosine of 45 degrees. It's only 22 degrees. No, it's not. It's wrong. I'm afraid. There's no way, because it's only 22 degrees. Even double is just 4. It's positive. Oh, weird. Where's my pen? All right. Erase this stuff. Let's try it. Oh, okay, wrong thing. What? So, let's start over. Doesn't matter. And we're going to start over. Let's do this again. It happens. Unfortunately. Alpha cosine theta. Let's see. Actually, I'm not going to start over. Let's just pretend I'm doing 24. It's the same. See one, see them all. Nah, let's not start over. 24. Actually, let's not start over. let's not bother. Okay, we'll just pretend that we're doing problem 24 because 24 is asking exactly this problem about sine 2 theta and cosine 2 theta and tangent 2 theta as well. So we'll just pretend that we're doing problem 24, and and problem 25 works the same way. So next we need to do tangent 2 theta, and then we're not even going to bother with anything because tangent 2 theta will be equal to sine 2 theta over cosine 2 theta is this number divided by this number, which is 120, and divided by 169. Sorry, divided by 119. And that is that. That's all there is to this tangent 2 theta. Just this divided by this, which we cancel out the denominator, and so this is the answer. Okay, and that's that. So let's move on. So next, let's look at problem 41, and where we are supposed to reduce this thing. Well, to reduce it, we shall use the reduction formulas, where sine squared equals to that stuff, and so on. Okay, so now we have a sine fourth formula. To do that, we will, I guess we will just sine to the fourth power is 2. Now, did I write that right? Let me check. So before we start, I want to mention that notice that this is identical to example 5 on page 853. That is this one right here, where we to reduce the in this case we did cosine fourth. To reduce cosine fourth, we factor into 2 and like cosine squared multiplied by itself, and then reduce it into so that it got reduced to the cosine squared, and then we have to apply the reduction formula again. And so in this case, we are doing sine to the power fourth, but we're going to follow this exact pattern. Okay, so that is that. We have following the formulas, following the same pattern. Then we have sine fourth will be sine squared, which is sine squared times 3x, sine squared of 3x, and then we'll square it again. So then we need to figure out what is sine squared 3x. Sine squared theta is equal to 1 minus cosine. So that we'll let this 3x will be called theta. Okay, so sine squared theta. Let's see, sine squared of 3x. I don't have to write this down. So this is equal to, following the reduction formula, which is, I'll write down this parentheses, 1 minus cosine of 2 theta. Okay, I'm following this thing, the sine squared one. 1 minus cosine of 2 theta. Theta is 3x, so cosine of 2 theta will be 6x. So I'll write that down. Cosine of 6x, and then divided by 2. I'll put these in parentheses. And then we need to multiply this thing out. That would be equal to, let's see, let me write down the formula here. If we do 1 minus a and square it, that would be equal to 1 minus 2a plus a squared. Okay, that's the formula we follow. And you can verify that by multiplying it out. But anyway, so this is equal to 2 squared is a quarter. So we'll write down the quarter right here. My marker is not thick enough. Okay, and then so this becomes 1 minus 2 cosine of 6x, and then plus cosine squared of 6x, following this formula right here. And here is the close parentheses, and everything here looks okay except for this thing. This thing we need to expand it some more because we can't have anything to the second power. So to expand this, we have anyway, so to expand this, we will follow this part then, just this part. Okay, we'll follow this plan where now the new theta will be 6x. This is the new theta. This is different from that theta. That theta is only 3x. Now we have a new theta, which is 6x. So following this form, plugging it into this formula for the cosine squared, then this thing then equal to 1 plus cosine of 2 of these. Sorry, when I say this is theta, I'm talking about the 6x only. It's not supposed to include the other stuff. So this is the theta, okay? And so cosine of 2 theta then becomes 12x. 12x divided by 2. So that is, so this equals to that part. Now, so now let's multiply the whole thing together. That will be equal to 1/4 times 1. That is just 1/4, okay? And then 1/4 times 2. That is becomes 1/2 cosine of 6x. And then lastly, if 1/4 times this is times half, that is gonna be that be 8 down here, and then 1 plus cosine of 12x. Cosine of 12x. So you can break that into 1/8 and then cosine 12x over 8. So the 1/4 will be added to the 1/8 here, and then the whole thing will become 1/4 plus 1/8 will be 3/8. So the total amount of numbers in this equation will be 3/8. But otherwise, the rest of it will be the same. So it will be 3/8, and then plus this, minus that, and plus that. Okay, and that should be the answer to problem 41. Let me check. And the answer is correct, okay? Upon checking the answer at the back of the book, and they write it in all under one fraction, which is okay, but it's not required. You can write it in separate fractions or all under one fraction. If it's all under one fraction, then this number becomes 4/8, and that's the only difference. Okay, so next. So next, let's consider problem 55. Now we have we are supposed to prove that sine 2x equal to 2 tangent x over 1 plus tangent squared x. We can do this several ways, I suppose. Well, a quick way would be figure out what is 1 plus tangent squared. Now, there is a formula in the past that you can figure out by doing division. If you divide this Pythagoras theorem by cosine squared theta, then sine's the whole thing, okay? If you divide everything by cosine squared theta, then this is sine squared over cosine squared, which is tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant, okay? Cosine's inverse is reciprocal is secant. So then tangent squared theta plus 1 equal to secant squared is another way to say the Pythagoras theorem. So then we have 1 plus tangent squared x, okay? So this is the same as secant x. So we can write that. Basically, this is secant. This thing here is secant x. Secant x squared. And see what is, so then we can write it this way. At the right hand side, okay, this stands for the right hand side. The right hand side is equal to 2 tangent x divided by secant x. So to divide by, okay, I'll write it down. What is secant x? Secant is 1 over cosine, okay, cosine squared x. And then to divide by something is to invert and multiply, which is equal to 2 tangent x times cosine squared x. I think I forgot something. Is there a square? Maybe I'm okay. I just want to make sure. Actually, I think I'm fine. Never mind. Anyway, so that equals to 2 tangent x cosine squared x. And continuing, that would be equal to tangent is sine over cosine, 2 sine x over cosine of x, and times cosine squared x, and that will be remember the square means the entire cosine x is being squared. So this cancels out to have just one left. So we have the answer then is equal to 2 sine x cosine of x. And what is 2 sine x cosine of x? then by our, this is the double angle formula, okay? 2 sine x cosine x is the same as sine 2x. So then we can write that out. So this equals to sine 2x, and which is exactly what's on this side. So we are done. Equals to the left hand side. LHS this is how some people write it. Okay, the right hand side is equal to left hand side is how you prove. Some people prove trigonometric identities. So that's problem 55. Next. Now, before I erase this, I should mention that if you don't remember that 1 plus tangent squared equals to secant squared, you don't have to. All you have to do is turn all tangents into sines and cosines and work it around, and they'll all come out as well. Okay. In fact, that's not necessarily a worse way of doing it either. So either way works. So next, let's do problem 56. We have 1 minus tangent squared, and then 1 plus tangent squared. Now we know that tangent squared plus 1, this one is secant squared. So we'll start here and work our way around and see how this might work out. So this is so the right hand side. Okay, that's referring to the right hand side of the equality symbol. The right hand side, we'll write it down here, is equal to right hand side equals to 1 minus tangent squared alpha, and then divided by secant squared alpha. Okay, and that is equal to 1 minus tangent squared alpha times, to divide by the secant is 1 over cosine, so to divide by secant is the same as multiplying by the cosine squared. Okay, you can pretend secant as 1 over cosine, and when you divide, you invert and multiply. So invert the 1 over cosine, this becomes cosine over 1, which is right there. So then continue multiplying. Okay, so this multiply out to be cosine squared alpha, and then tangent times cosine. Tangent is sine over cosine, right? So the tangent is sine over cosine, remember that. And so then they are squared because this one's squared. So when you multiply by when tangent times cosine, the cosine will cancel each other out, so we only have the sine left. So it becomes minus sine squared of alpha. So here's this, and how does this relate to this one? Let's check the charts and see what it says. Here's the chart. The chart says that cosine 2 theta is, among other things, it equals to cosine squared minus sine squared. Okay, that's exactly what we have here. Cosine 2 alpha equals cosine squared minus sine squared. So the right hand side is equal to the left hand side. So we are done. Okay, and that is problem 56. Next. But I should mention that you might not, if you don't notice or remember that this is secant squared, you can just turn the tangents into sine over cosine, and then work on the fractions, and everything will come out the same way. It doesn't really matter how you do it, okay? There's more than one way to skin the cat. So next, let's consider problem 57. We're supposed to prove this equation. So to start with, let's start on this side. So tangent 2x, okay, the left-hand side, which is tangent 2x, is equal to, tangent is sine over cosine, so let's write that down, equal to sine 2x divided by cosine of 2x. And that equals to, what is sine 2x? Let's find some formula here, okay? Again, sine 2x equal to 2 sine x cosine x, according to this formula. So let's write that down. That equals to 2 sine x cosine x. And as you notice, that's exactly that. Wow, same thing. And then the cosine 2x, let's dig out a formula too. Which one should we dig out? See, there are various cosine ones. Now, comparing it to what's on the board down here, okay? Compare it to the, can you see that? No, not really. Okay, and now we need to look for something that cosine 2x need to be equal to 2 cosine squared x minus 1. And look over here. This one, let's choose this one. It says 2 cosine squared theta over minus 1. So cosine 2x equal to 2 cosine squared x minus 1. And that's exactly what we're trying to prove. So this is equal to the right-hand side, and we are done. Here we go. All right, so that was a quick deal. Next. So next, let's do problem 61. Okay, problem 61, we have 1 plus cosine 2t. Maybe I should look at it to make sure I copied it right. 1 plus cosine 2t over sine 2t minus cosine t equals to 2 cosine t over 2 sine t minus 1. All right, that should be okay. Let's start on this side, because this side looks more complicated, and so we'll work with it and see if we can reduce it to look more like the other side. So that's what we're going to do. Now, let's see, 1 plus cosine 2t. So let's use the double angle formulas to see if we can get anything to come out. Okay. So starting on the left-hand side, LHS is equal to 1 plus cosine 2t. Cosine 2 theta equals to various things here. We will choose it to be, well, whatever. And let me think. Yeah, anyway, let's do that. So 1 plus cosine 2t, which is 1 plus, we'll have 1 plus, we'll follow the cosine 2 theta. The 2t will change it into the first one. Okay, let's pick the first one. No reason. Let's just pick something and stick with it. So 1 plus cosine 2t is equal to 1 plus cosine squared t minus sine squared t. Right? I'm following this formula right here. Cosine 2t is cosine squared t minus sine squared t. And I followed it right here. And so then, and now in here, and then next, that's the top. We'll leave that for now. And then sine 2t. Sine 2t has only one formula to follow, so we'll stick with it. Sine 2t is 2 sine t cosine t. So let's write that down. Sine 2t then becomes 2 sine t cosine t. Cosine, what happened to my cosine? C-O-S-T. Okay, then minus cosine of t. So the next step is this equals to 1, look in here, okay, 1 minus sine squared. From the Pythagoras theorem, if we move the sine squared over there, that will becomes 1 minus sine squared theta. So that equals the cosine squared. So that's what we're going to do. So these two things, okay, together, this one and this one together becomes cosine squared t. So then the top becomes cosine squared t plus cosine squared t. This is a plus, okay? And so then 1 minus sine squared equals the cosine squared. So the top becomes a total of 2 cosine squared t. And then the bottom, we have, this is a cosine t minus cosine t. So let's factor that out. So this will be cosine of t. And then what's left is 2 sine of t minus 1. Okay, so let's cancel something out. We can cancel out 1 cosine t. There's a cosine squared t. There's cosine t. So we can cancel out one of them. Okay, so we'll just get rid of that, the squared. So this will be equal to, what is that? That is exactly this thing, right? Because of 2 cosine t over that's gone, so over 2 sine t minus 1. So this is going to be equal to the right-hand side, and we are done with the proof as well as this section. But remember that always that when it comes to proving trigonometric identities, there is more than one way to skin the cat. You might want to do something different, okay? Like you might choose a different cosine squared formula, but it will all work out. Doesn't really matter how you do it. It will all come to the right answer. Or you can even start on that side and multiply it by something. Maybe multiply it by, if you start on this side, you can multiply the top and bottom by cosine t, and then work your way up to make it look this way. Okay, you're just trying to make one side look like the other side by doing stuff to it, until something happens. And okay, that should be the end of this section.